Hi, this is Brandon Baines in the Math Department at Lipscomb University, here to talk with you today about linear equations. In this presentation, you'll learn how to determine if a given x value is a solution to an equation, and you'll also learn how to solve linear equations using properties of equality. A linear equation is a statement of equality involving a single variable raised to the first power and constants. Some examples of linear equations include 3x plus 5 equals 7x minus 9, 2 times the quantity x minus 1 equals 4, and 3 times x equals 0. Solving an equation is probably something that we've all had to do at some point, or at least something we've heard. Find x, that sort of thing. So what does that mean? What does it mean to be a solution to an equation? Well, it means that we've found the value of the variable that makes the equation true. So, for example, in the equation negative 2x plus 2 equals x minus 1, the solution to this equation is x equals 1, because when x equals 1, we have a statement of truth, namely that 0 is equal to 0. Let's see if we can determine whether we're looking at a solution or not. Is x equals 4 a solution to the equation 9x minus 5 equals 12? Well, again, like we've said, if it is, then when we substitute the value of 4 in for x, we should get a true statement. If we get a false statement, then we'll conclude it's not a solution. All right, when we substitute that value in to the equation 9x minus 5 equals 12, and we let x have the value of 4, we get the statement 9 times 4 minus 5 equals 12. This is 36 minus 5 equals 12. That's not a true statement, and so x equals 4 cannot be a solution to this equation. When we solve an equation, we use several properties of equality to do that. Namely, we use the addition property of equality, which states if you have a statement of equality like a equals b, then you can add the same quantity to both sides of that equation. And here we're using c as the name for that quantity. We have the subtraction property of equality. It says if you have a statement of equality like a equals b, then you can subtract the same quantity from both a and b, and you'll still have a statement of equality. The multiplication property of equality, it states if you have a statement of equality a equals b, and you multiply both a and b by the same quantity, then you still have a statement of equality. The division property of equality states if you have a statement of equality like a equals b, and you divide both a and b by the same quantity, which we're calling c here, then you'll still have a statement of equality, provided, of course, that c is not 0. C can't be 0 because we cannot divide by 0. When solving an equation, we're very interested in ones and zeros. In general, we want to isolate the variable, and to do that, we try to make constant terms add to 0, and we often want to make the coefficients in front of the variable 1, so we'll use multiplication to do that. Here's an example. We're going to solve the equation 4x plus 3 equals 9x plus 8. To begin, we'll use the subtraction property of equality, and we will subtract 3 on both sides. And so we've done that here. And when we do that, notice that 3 minus 3 is 0. Okay, so we're making 0. And when we do that, that leaves just a 4x on the left-hand side and 9x plus 5 on the right-hand side. To isolate x, it would be nice if all of the x's were on the same side of the equation. So we can use the subtraction property again and subtract 9x on both sides of the equation. When we do that, we get negative 5x on the left-hand side, and we're still left with just that 5 on the right-hand side. Finally, to isolate x, we will multiply by negative 1/5, or you might say it is divide by negative 5 on both sides of the equation, using that division property of equality. And that results in x on the left-hand side and negative 1 on the right-hand side. So x is equal to negative 1. It should be noted that you can check your answers. I'll toggle back here. We found x is equal to negative 1. We can always check that. Remember, a solution to an equation should make the equation true. So we plug negative 1 back in for x, we should get a true statement. Let's take a look at a second example. We have the equation x divided by 3 minus 2 is equal to 3 times the quantity x minus 7 minus 5. Well, first we'll distribute this 3 here so that we have all of our terms sort of pieced out. So if we distribute the 3, we have 3x minus 21 minus 5. From there, we can combine like terms. We'll combine the minus 21 and the minus 5 to get minus 26. From there, we use the addition property of equality and add 2 on the left-hand side and on the right-hand side. Note again here that the addition of 2 is making 0. There's a sum of 0 here. That leaves us with x over 3, or x divided by 3 on the left-hand side, and 3x minus 24 on the right-hand side. If we multiply by 3 on both sides of the equation here, we'll have 3 times x over 3 and 3 times the quantity 3x minus 24. That multiplication by 3 results in an x on the left-hand side and 9x minus 72 on the right-hand side. Again, we have x's on both the left-hand side and right-hand side of the equation, so it'd be nice to isolate x. We need it to be on one side of the equation. We need all those terms. So using the subtraction property of equality, we can subtract 9x on both the left-hand side and the right-hand side. Again, note that subtracting 9x results in a difference of 0 on this right-hand side, so that's very helpful, and leaves us with negative 8x on the left-hand side. So this statement, negative 8x equals negative 72. Using the division property of equality, we can divide by negative 8 on both sides of the equation. Notice that negative 8 divided by negative 8 is 1, okay, 1x. So 1x is equal to 9. Again, we could check our answer by plugging in.